Hey Math 1, I got a lesson for you guys, 1.10 notes. Really, I'm just going to give you two examples of proofs when you're combining like terms and give you a look at two where the proofs are complete, but you just have to fill in the properties that go along with them. You guys learned this from lesson 1.9. This is literally just to give you a couple fresh examples that include maybe some of the more difficult aspects, decimals, and fractions. So hopefully this is helpful. Let's get started. So simplifying each expression, we have three properties that we're kind of moving through. Distributive property, which is the get rid of parentheses through multiplication. The commutative property, get the like terms together so that we can add or subtract them. And then the substitution property is when we actually make those calculations themselves. Usually the final step. So on this right here, I see grouping symbols, parentheses, so I'm going to multiply by whatever's on the outside. Now, I'm not going to multiply by 7.2. I am not going to multiply by 7.2 because there is subtraction here. Subtraction is not multiplication. Subtraction is not multiplication. There's an implied 1 right here, which is what we're going to distribute through to these parts. So take negative 1 times 3x, gives you minus 3x. Take a negative 1 times negative 3, that gives you plus 3. Okay. Here, I'm going to multiply everybody by 2.1. I can do some scratch work off to the side if I need to. So 2.1 times 3 would be 3, 6. And don't forget that you have to manage those decimals properly. If this is 2.1 times 3, you need to move the decimal point in. Sorry, there's a glare there. So you guys got to pay attention to those details. The decimals have to be honored when you multiply. So it's a positive 6.3, and then you take positive 2.1 times negative 10x. I'm hoping we're starting to see the patterns where I don't have to go off to the side and stack 2.1 and 10, but thinking, hey, if I multiply anything times 10, I just move the decimal place over. So 2.1 times negative 10 is negative 21, and then we have to tack on that x at the end. Make sure you drop the 7.2. We would back that up with the distributive property because that's the one that gets rid of the grouping symbols. It gets rid of the parentheses. Next one is the property in which we need to rearrange things so that the like terms are side by side. So I'm going to flip around the 3 and the negative 3x, put a positive 3 here. And then the negative 3x is here. I'm going to flip it again with the plus 6.3. So now it's side by side with the 7.2. That leaves the negative 3x over here now, and it's subtracting 21x. Yeah, we can just say that this is the commutative property. Okay. So now think about these three. I'm going to stack the 7.2 with the 6.3 first, and then put the 3 at the bottom. Although, I think you guys can do this in your head. 3 plus 7 is 10. You can just call that 10.2. But I have a sneaking suspicion that this is how you guys are going to do it, so I'm going to do it this way. So 2 plus 3 plus 0 is 5. We don't carry anything to the next column. 3 plus 6 is 9. Plus 7 is 16. All right, So 16.5 is this part right here. And then negative 3 minus 21 is going to be negative 24x. Because if it's minus, minus, I am going to stack them and add. And because they were both negative, the end results will be negative. Don't forget the x. All of this was the substitution property. And you're done. Let's do that with number 2. Same situation here. I'm subtracting a 1 group of parentheses. So distribute the negative 1. All it's going to do is make these opposite what they already are. So positive 1/3 x, it's now a negative 1/3 x. Positive 3y, now it's a negative 3y. 2y just drops down. All right, negative 3 multiplied by 1/6. This is where you're probably going to need to utilize some space off to the side. I'm just going to erase part of this proof and use that space. So what's negative 3 times 1/6 x? Well, you can put the negative 3 over 1 and then do one of two things. Multiply straight across and then simplify it, or simplify it first through cross cancellation. 3 divided by 6 is 1 over 2. So this is really negative 1 times 1, negative 1 over 1 times 2. Yeah, it's a half. So then take negative 3 times negative 1/2. I'm just going to, put it over 1 right away. There's a y there. No cross cancellation, but I know a negative times a negative will be a positive 3 over 2y. That's the distributive property. Now let's rearrange some things. I want to get the y's side by side. So 2y minus 3y, remember always the sign to the left of it gets carried with it, plus 3 over 2y. And then we've got negative 1/3 x minus 1/2 x. Commutative property rearranges things. So now maybe you got to do some more scratch work off to the side. So, I don't think we got to stack this. 2 minus 3. Take the difference, 1, make the bigger number its sign. So it's negative 1. So this is negative 1y plus 3/2 y, which, I could make them both fractions, but this is just 1/2. Negative 1 plus 1/2 is 1/2 y. But I'll show you guys the common denominator because I have a sneaking suspicion that a lot of you are going to use this approach. Times 2 times 2, that'd be negative 2 over 2y plus 3 over 2y. Negative 2 plus 3 is a half, or 1 over 2 is a half. So 1/2 y is what those y's simplify down to. The x's, negative 1/3 x minus 1/2 x. Find common denominators. So 6 times 3 times 3 times 2 times 2. That'd be negative 2 over 6x minus 3 over 6x. Yeah. And like on that previous one, if it's a negative that's subtracting, you're really adding the 2. And then it's going to be negative. Here's a visual of what that looks like in case you're still bewildered by this. Let's say you got a number line. Okay? 0, 1, 2, 3, 4, 5, 6, 7, 8, whatever. So here's what they're saying. Here's what I'm saying. Let's say you start at negative 2 on this number line. This means go left 3 units. 1, 2, 3. I'm at negative 5. So it's like I added 2, and then I added 3 more together. So hopefully you guys are doing well with wrapping your mind around that. If you're still struggling, don't give up. So this negative 5 over 6 replaces, negative 5 over 6x replaces this using the sub property. And that's the simplified version of the expression. Okay, so maybe not too terrifying, but we just got to figure out where we're making our mistakes with decimals and fractions. The big thing, though, is that you know how to find common denominators. It's just maybe you're messing up, like you're saying 3 plus 3 is 9 or something like that. All right, I'm going to show you guys now the 2 proofs on the back side of those note sheets in which you have to fill in the gaps with a proof that's already given to you. All right, so we're given a full proof right here. Start with the given. What changed to get to line 1? We had grouping properties, grouping symbols, parentheses, they're gone now. That's the distributive property. All right, so here's a little piece of advice. The grouping symbols are gone. We're never going to use the distributive property ever again in this proof. So you can almost just sort of check that off and say, all right, we're down to a 50-50 shot. It's either going to be commutative property or substitution now. Or wait, commutative property or substitution on every single line below that. I guess I'm saying that's good news. So then you're here. What changed to get to there? So 8b is still there, negative 10a is still there. I had negative 18 minus 15, and now it's negative 33. The plus 21 remains, the plus 21a remains unchanged. This was a substitution of negative 18 minus 15, calculated, and you got negative 33. See, the terms were already, they're already side by side, so we didn't need to use the commutative property to move things around. Interesting. All right, on the next one, the 8b is the same. It looks like the negative 10a and the negative 33 flipped around. They were rearranged. That's the commutative step, is the rearranging step. From here to there, looks like we lost a couple. Yeah, these two were computed, and you got 11a out of it. Looks, it's like when the lines reduce in their value here, that means that you're going to have sub. What I mean is, like, we dropped out a few terms. It's sub. We dropped out a few terms. It's sub. We didn't drop out commutative. We didn't drop out. We just rearranged these two terms. Also commutative. So yeah, I mean, I'm just saying there's some shortcuts you guys can use to kind of keep you centered and grounded so that, you know, even if you're kind of got wonky thinking on any days, it's like reduced, substitution. Reduced, substitution. Same number, commutative. Same numbers, commutative. Yeah. All right. I know the video's over 15 minutes now, but I'm just going to try on those last two. Like, we'll squeeze in this last example. All right. Ooh, this is weird. I still have grouping symbols. It's usually distributive property the first time. So what's different? 7y, 7y, plus, plus, parenthesis, parenthesis, y, y, x, x, 2, 2, minus, minus, y, y, 3, 3, minus, minus, x, x, parenthesis, parenthesis, 2, 2, minus, minus, x. Oh, there it is. A yx flipped around or rearranged to be an xy. The commutative property works for multiplication. Now it looks like we get rid of parentheses. So from this step to here, parentheses gone. We multiplied the -2 through to all parts. Then it looks like the plus 4xy made a move to the front end. And the -2x plus 6y moved a little bit over. They moved, they rearranged, they commuted. Oh boy. Yeah. And now it looks like we're consolidating. We're bringing them together. 3 plus 4 is 7xy. 6 plus 7 is 13y. That's substitution. And then once again, it just looks like we rearranged it so that the plus 7xy is at the tail end. All right, guys, I hope this was helpful and more clarifying than that first video was after you get a few practice examples. Hopefully we're piecing it together. Thanks for watching.